Welcome to Module 4, Lesson 2, Part of a Whole as Percent. Okay, so we will look closely at what it means to be a part, what it means to be a whole, and what it means to be a percent. Okay, because there is quite the challenge, or rather, let's call it a major stumbling block with students attempting work with percentages, and that's identifying the whole. Okay, identifying what in the problem, especially when solving word problems involving percents. Okay, because very often word problems will will be presented in a way where it's maybe not necessarily clear at first blush what is the whole that is being referred to, what is the part, okay, or what is the percent. Okay, so that's what we're going to undertake in this lesson. Okay, so for an example, as a percent, how does the value of a nickel compare to the value of a dollar? Okay, so question here is we want to know as a percent. Okay, as a percent, how does the value of a nickel compare to the value of a dollar? Well, we identify the whole. Okay, and the whole is the dollar. Okay, and this dollar can also be referred to as 100 cents. Okay, 100 cents, and we talked about this idea of making fractions initially with the denominator of 100, because that they can easily be converted into percentages. Okay, and then the part is the 5 cents. Okay, so we've talked now about the whole and about the part. The only thing left is the percent, and in this case 5/100ths, or 5 out of 100, or 5 per 100, is also known as 5%, and that's how we write 5% right over there. Okay, we could also write it 5/100ths as a decimal, which is 0.05, which of course is 5/100ths. All three of those are equal. So the whole is the 100 cents. The part is the 5 cents. And then the percentages, of course, was 5%. Okay, so let's move on now to this opening exercise. Okay, in this opening exercise, we are going to ask in Part A. Let's do Part A first. Actually, I'm going to have you pause here and go ahead and tackle Part A. But in Part A, we are only interested in the whole. Okay, what is the whole in these different scenarios? Okay, so read the scenarios on the left, and then go ahead and write what that whole unit is. So, for example, let's just do that first one. Okay, 15 is what percent of 90? Okay, we're not doing any calculation. We're only identifying. We're identifying what the whole unit is. That whole, what is represented as the whole in that problem. Of 90, and I want that to play a very, very important part in your identifying of this whole, and that is that word of 90. Okay, that is going to indicate that 90 is your whole. So 15, that's your part. Okay, 90 is the whole, because we can see 15 of 90, what percentage is that? And of course, in this case, the percentage is something that we don't actually know. That's an unknown presently. Okay, but I don't care about the part, you identifying the part or the percent or whatever, just the whole unit. So go ahead and do those 1, 2, 3, 4, 5 that are left, and come on back and let's see how you did. Okay, so let's go ahead and do this. What number is 10% of 56? Okay, now that's a very different problem than the one prior to it, but not very different, but it is different, asking for something different. But still, we can identify the whole by looking at that part there, that phrase of 56, and we know that 56 is our whole. The next one, here we go again. Oops, I forgot to pause there. 90% of a number is 180. Well, now our whole is the unknown number. Okay, so in this case, we knew our whole. In this one here, we don't know our whole. It is actually the unknown. Okay, we know the part, we know the percent, but we don't know the whole. Okay. Next one, a bag of candy contains 300 pieces, and 25% of the pieces in the bag are red. Well, yeah, 300 pieces. Okay, if it gives us there a bag of candy, okay, that is the whole thing. 300 pieces. Okay, 300 pieces or 300 pieces of candy. Okay, the next one, 70%. 70% of the students earned a B on the test. This is another one of those of the students, and that is unknown. So all the students, okay, we have a percent. We have students earned a B on the test. We have the part. Do we have the part? Yeah, that's the part. That's the part and the percent. We don't know, actually, part and percentage. We don't actually quite know. That one is an interesting one. But in this case, the whole still is going to be all students, 70% of all those students. Next one, the 20 girls in the class represented 55% of the students in the class. Here we have the part, we have the percentage, and of course, we have our students, again, all students, as the unknown whole. Okay, unknown whole. Okay, let's move on here to B. And now B asks us to read each problem and complete the table to record what you know. Okay, so now, whereas here we were looking solely for the whole up here, looking only for the whole that was represented, or what the whole was represented as. Down here we're going to look at the part. You have to identify in these scenarios, okay, over here, the part, the percent, and the whole. Okay, so you need to represent what represents all of those, and let me just give you a clue. Yeah, there's going to be an unknown. Okay, so and it could be the part, could be the percent, could be the whole. So go ahead and give that a whirl, and come on back and we'll go over it. Okay, so let's go ahead and look at this first one. So right away, let me read this though, but 40% of the students on the field trip love the museum. If there are 20 students on the field trip, how many love the museum? So the first part I highlighted there, 40% of the students, well, that would tell us that we have our percentage. Okay, we have our percentage, which is 40%. And we know if there are 20 students on the field trip, we have our whole, okay, 20 students. Therefore, our part is going to be our question mark or our unknown, okay? So 40% of 20, how much is that? And then we will know the answer to our part, question mark there, okay? The next one says, again, we start off with 40% of the students on the field trip love the museum. Okay, if 20 students love the museum, a little bit change here, how many are on the field trip? Okay, so in the one prior we said if there are 20 students on the field trip, so we knew that whole. Okay, but now is if 20 students love the museum, that is going to represent, of course, 40% represents our percent. But now we have that part. We have the 20 students because this 20 students love the museum. That goes along with the 40% that was mentioned. So these two are the same in the sense. 20 students, it represents the same as 40% of the students. But it's that whole this time that we do not know. Okay, we are not being given the whole in that sense. Okay. Okay, so next one here, 20 students on the field trip love the museum. If there are 40 students on the field trip, what percent love the museum? Well, we're given that 40 students. Again, like the first one, we knew the whole. We know the part, okay? But now we're being asked what percent. So therefore, our percent is our unknown. So you can see how in each of these there was a different unknown. Unknown was the part here. Unknown here was the whole. And unknown in this one was the percent. Okay, so identifying what each part of the problem represents, very, very good starting point. Okay, so let's have you work through this example 1 here, visual approaches to finding a part given a percent of the whole. So in Ty's math class, 20% of the students earned an A on the test. If there were 30 students in the class, how many were given an A? Okay, how many were given an A? So in this case, we are going to focus on visual approaches. Okay, so let's go ahead and start that. Okay, so here we go. In Ty's math class, 20% of the students earned a, excuse me, I can't read this because I've got something over it here, but in Ty's math class, 20% of students earned an A on the test. If there were 30 students in the class, how many got an A? Well, you can pick out some of these parts here. We have a percent, okay, and then we have the whole, okay, the whole. Now, this whole of 30, okay, and the way we're going to do this, we're going to draw 2 number lines side right on top of each other, one another, to do some comparisons. But just to know that number 30 also represents the 100% of the class. That's something to know, because if you know there are 30 students, then that is going to be 100%. Okay, only 20% of them got an A. Okay, so let's go ahead and draw this thing here. Okay, so there we go. Two number lines of equal length, one on top of the other. You could use your grid paper to do this. Okay, and now I have I draw in there. I have 0 to 100. That first number line, the top number line, represents the percentage. Okay, that's a percentage scale. Okay, the one on the bottom are the number of students in the class, and you can see if we look right here how 100% corresponds to 30 students. Over here, of course, 0% of the students is actually 0 students. Of course, 0% of anything is 0. Okay, so these 2 number lines, one on top of the other, is a way to look at this visually. Okay, look at it visually, because whatever is on the top as a percent corresponds to the students below it. Okay, that percentage is going to be represented by that number of students, and that number of students represents the percentage above it. Okay, so if we go ahead and just mark that point where what we are looking for, we're looking to uncover 20% of the students, and believe me, I'm going to draw on this number line, and it is not to scale. Okay, very much not to scale. So sorry, but yeah, bear with me. But you can if you're using your grid paper, much easier. So we're trying to find that unknown right there, the red question mark here. What number of students corresponds to 20% of the class? Okay, so what I can notice right away, okay, and I'm always looking for relationships like this, and with 100, it's pretty easy to do. You can see that we can actually split this up. Since we're trying to find 20%, well, how many sections of 20% are there on this number line? And there happen to be 5 sections, as you can see there, from 0 to 20, 20 to 40, 40 to 60, 60 to 80, 80 to 100. Okay, those are all equal, as they don't look it, okay, because I said it's not to scale, but those are equal sections, okay, equal segments of that number line. Now, below it, there are numbers of students that are going to correspond to those percentages, okay? So, right there, so we have 1 segment there, 2 segments, 3 segments, 4 segments, 5 equal, and that's what's really important, 5 equal segments also that correspond to the equal segments on the number line above. Okay, so the number is 30 that we're looking at because the whole number line of students is equal to 30. So if we split that 30 up into 5 pieces, 5 sections, okay, each of those sections is going to be worth 6, okay, 6. As the top number line, the percentage number line, each of those sections was equal to 20%, okay. Below that, the student number line, each of those equivalent sections is equal to 6 students, okay. So there we go. So at that 20%, we have 6 because that's our first section. And then we have 12. And then we have 18. Then we have 24. And of course we have 30, which is equal to 100% of our students. But the answer we were seeking was how many got an A, and we know that 20% got an A. And if we match that visually on these two number lines, we see that 20% is equal to or represented by 6 students. Okay, which I think is a really nice way to do it. So anyway, let's go ahead and exercise 1. I'd like you to go ahead and give this a whirl. Try to do it visually like this, a visual approach, just to practice. Good to practice with varying approaches. So let's go ahead and read it here. In Ty's art class, 12% of the Flag Day art projects received a perfect score. There were 24 art projects turned in by Ty's class. How many of these art projects received a perfect score? Okay, and very, very specifically here, they want you to identify the whole, and maybe that's the only thing they want you to do here. Let me just look through my notes. Okay, well, yeah, let's go ahead and solve for that, okay? And let's give it a whirl, try it visually, and come on back and we'll do it together. Okay, so here we go. Now this one, I've drawn my two number lines, so I'm going to do it the same way up here, but it's not as clean as the other one because we are now looking at, we're looking at 12%. Now, there's not an even number of 12% pieces that we can split that top number line into, so it's a little bit strange. So if we can't use that number, we're going to have to revert to using the 100%. So if in doubt, we can go ahead and split the number lines into 100 different pieces. Okay, now I'm just, and etc. I just went ahead and did it there, to 12 pieces. I'm not going to draw all 100 little lines there, but so there we go. We have that. So that 12 pieces. So each one of those is each percentage line equals 1%. Okay, so each one of those lines on that percentage number line is 1%. Okay, and down the bottom, if we went ahead and split that up again into the same number of lines, which you need to do if you're going to make this line-to-line comparison, you would find out that you have a total of 25. Okay, and you have 25, and you have to split 25 into 100 pieces, and if you do that, of course, you have 25 100ths, and that equals 0.25 per line, or 25 hundredths per line. Okay, each line is 25 hundredths. Now, that 25 hundredths, or 0.25, is also known as 1/4. Therefore, if we take these 12 lines, this is the 12th line right here, okay, and we multiply that 12 of those lines by 1/4, because each of those is worth 1/4, okay, we get 12 over 4, which is okay, so now we're going to move from the visual methods that we just used. And again, this is just to help you certain circumstances, I mean, many of you are going to know how to do this numerically, which is what we're about to approach. But the visual may indeed help, and sometimes when you just when you don't quite know what the whole is, represent it visually, and that would be a good place to start. Okay, so here we go. The numeric approach to finding a given given a percent of a whole. So we're going to find the part. Okay, in this case, we're going to find the part. All right, given a percent of the whole. All right, let me go ahead and read this to you. In Ty's English class, 70% of the students completed an essay by the due date. Okay, there are 30 students in Ty's English class. So how many completed the essay? We know the percent. We know the total. We are seeking to find the part. Okay, so go ahead and just mull over that a little bit. Come on back and let's go ahead and do it numerically. Okay, so while there are many ways to do this numerically, one of the easier ways is the way I'm about to do it. I think anyway. It's not one that I saw actually in these notes. There is another one which, I don't know, it doesn't seem quite as clear to me. But anyway, I'm going to go ahead and do it. You guys will just decide on your own what you find to be the most beneficial for you. Okay. So the way I looked at it was this: 70 over 100 is the same as 70%. So I'm going to represent 70% as 70 over 100, or 70 out of 100. Okay, and that is going to be equal to question mark, which is my unknown, over over 30. Now, the 30 represents the total kids in Ty's English class, so we have unknown out of 30. Okay, so percent, just what it does actually, that's 70 over 100, just says, hey, if you had 100 kids in this class, 70 of them would have gotten A's, okay, on this exam or this essay. Okay, hold on a second. Is that what it says? Is this about a grade, or what is this about? Hold on a second. This is completed the essay. Okay, this is about the completed the essay. And yeah, so because that's the way percentage is looked at. It's always used in terms of 100. Okay, so in this case, if there were 100 kids in this class, 70 of them would have gotten this essay in by the due date. Okay, well, they're not 100. Okay, but there are 30. So we need to use this number as our whole. The part is what we are missing right now. Okay, so in this case, the best way to do this, or one of the better ways to do this, I think, numerically, is to look at the relationship between the 70 and the 100 here in this case. Okay, so look at that percentage. So 70 out of 100. Okay, so if we try to look at that percentage, we can see that that percentage is actually 7/10 of 10. Okay, so it's 7 out of 10, which means that 7, the relationship between 7 and 10 is that 7 is only 7/10 of 10. Okay, and we could actually do that. That 70 100ths, okay, can be reduced down to 7/10, which is a lot easier to work with. Okay. And then let's look at this relationship right here. So we're trying to find out now. All we are doing now is creating an equivalent fraction. Okay, a fraction that is equivalent to 7/10 or 7 over 10. Okay, and the way we've done this in the past is we've looked at that relationship, these horizontal relationships, 10 times 3. Okay, the way you get from 10 to 30 is multiplying by 3. And if that's what you do to your denominator, you're going to do the same with your numerator. Therefore, if you multiply 7 times 3, you get 21. So now we know our part, which is 21, and our whole, which is 30. We knew our whole already, but now we've uncovered our part. Okay, that part is 21. So 21 out of 30 students got this essay in by the due date. Okay, and again, the way we found this out numerically was simply by making equivalent fractions. Okay, and knowing which parts to use. So a lot of fun. Just another strategy, another way to attempt this. Okay, so let's go ahead and look at this algebraically here. Okay, example 3, we're going to talk about an algebraic approach to finding a part given a percent of the whole. Okay, so in this case, this example right here, we could just do this together. A bag of candy contains 300 pieces, of which 28% are red. How many pieces are red? Again, we have our whole, we have our percent, and we're asked for the unknown part. Okay, so of course, just kind of gave that away. Which quantity represents the whole? Well, that's the 300 pieces of candy. Okay, I'm just going to say 300 pieces. Right, that is our whole. Okay, now which of the terms in the percent equation is unknown? Okay, unknown. Define a letter or variable to represent that unknown quantity. Well, we've already recognized the unknown as being how many of the pieces are red. So I would say I'm going to go ahead and define a letter. I'm going to say, well, first of all, which of the terms? So we need red pieces is our unknown. Okay, all right, and I'm going to go assign a variable r for my red pieces. Okay. Now they're asking us to write an expression using the percent and the whole to represent the number of pieces of red candy. Okay? Okay, so since we know, so an expression, again, it's not an equation, just an expression, that's going to represent the pieces of red candy, which is R, okay, is that it's going to be, because R actually is going to be equal to 28% of 300, okay, so we can write that as, and again, we don't usually write something like this, 28% times 300. Generally don't do it that way. Okay, we usually leave that percentage sign off when we're this way, but we would represent that 28% in different ways. So we could represent that 28% as 28 over 100, okay, which could be times 300, or we could represent that 28% as 0.28 times 300. Okay, so these two are equivalent expressions that could be used to represent the portion that is the pieces of red candy. Okay, so if we go ahead and continue here and then just write and solve an equation to find the unknown quantity. Okay, well, the equation we're going to write is we are solving for R, and that's all we know is R, so we're going to have R equals, and we know what R equals. R equals this right here or this right here. I'm going to go ahead and use this, use the fractional representation. So R equals 28 over 100 times 300 over 1. Okay, and again, how wonderful fractions can be in these terms. So if we do that, we can go ahead and we can do some cross cancellation here, and we have 3 and 1. Okay, so multiply across, that is going to be 84 over 1, or 84. So R equals 84. So 84 pieces of the candy are red, and that 84 represents 28% of those pieces. Okay? Okay, so this exercise 2 is actually just an extension or continuation from example 3, just came prior to this. So in this case, again, we know some answers here that we could actually plug in, but let's go ahead and pretend that we do not know the answer to the how many pieces are red. Okay, and let's just look at this from a whole new vantage point here. So a bag of candy contains 300 pieces, of which 28% are red. Okay, and this is was the same first line from the last problem. But now the question is, how many pieces are not red? Okay, how many pieces are not red? Now we could indeed find out how many pieces are red and then just subtract those away, okay, which is one way. But another way, we could actually figure out right away which percent are not red. Okay, so in this case, this first one asks us to write an equation to represent the number of pieces that are not red, and we're going to use n as not red, so that would be n equals, and again we would try to use a percent first, so 100% minus 28% times 300. Okay, so we have the 28% that are red, so we want to subtract those away from the 100%, which is actually equivalent to all of them, which represents all the pieces of candy. The number, of course, which is 300. Okay. Now, an even maybe even better way to do this is we could go ahead and create fractions or decimals as well to handle this. So, for example, we could say n equals 1 minus 0.28, okay, times 300, all right, because 1 of course is 100%, 0.28 or 28 hundredths is equivalent to 28%. So if we went ahead and did this, we have a more numerical operation here, and then we could just continue this along, and we'll know that n equals, this is 0.72, okay, times 300. All right. And actually, I shouldn't get ahead of ourselves here. Let me just go ahead. Let me say use your equation. Here we go. Use your equation to find the number of pieces of candy that are not red. All right, well, I'm just going to continue this here. Bring this right down here. So I have something that looks like this. Now I can go ahead and I can multiply this using my calculator, or I could change this again into fractions, which are so useful in this case. Okay. 72 over 100, same as 72 hundredths. From above, do my cross canceling again, and then this is going to be 216 over 1, which of course equals 216. So 216 pieces are not red. All right, and I could compare that, since these are the same numbers, I could compare that by adding the not red to the red, which this is the answer we got in the prior problem. And that is indeed 300. Okay, alrighty. Okay, so now this part C here, let's see what this is. I haven't read this yet, but let's go ahead and read this together. So Jalil told his math teacher that he could use the answer from part B and mental math to find the number of pieces that are not red. Explain what Jalil meant by that. Okay, doke. Let's see. So Jalil told his math teacher, excuse me, that he could use the answer for part B and mental math. Let's ponder that and write down what you think, and I'll be back in a minute. Okay, well, I guess what Jalil meant is just what I said. That was this part right here. Once I know that 84 was the red, then I could just subtract 300 minus the 84, which equals 216. Okay, so what Jalil meant was that I could just go ahead, just like we talked about before, is that once I knew what the red were, I could just subtract those away from the whole bag and get the leftover, and that would be our not red pieces. Okay? Not as confusing, excuse me, as they make it to sound. Okay, so here in example 4, they are titling it here, comparing part of a whole to the whole with the percent formula. Okay, I'm going to present you here with a present, not present, but percent formula. And that percent formula is very, very simple. I don't think we've actually even mentioned it yet, but it just very simply means part, in this case, equals the percent times the whole. Okay, so we have a formula now. It's we're going to use algebraic reasoning, and we're going to use this formula to solve this problem here, example 4. Okay, so let me go ahead and read this. Zoe inflated 24 balloons for decorations at the middle school dance. Okay, if Zoe inflated 15% of the balloons that are inflated for the dance, how many balloons are there in total? Okay, let's go ahead and plug these numbers that we have in here to the percent formula, and then we can verify our answer using some sort of visual model. Okay, so let's go ahead and identify these parts. Now we have a part because these 24 balloons, they are not the whole, okay, because they only represent 15%. Okay, so this part is 24. That plugs in there, equals 15%, or 15 over 100, or 0.15. Okay, we could use any of these, preferably the latter two, times, in this case, W, because we don't have the whole. Okay, we don't know the whole. Okay, W or W. Okay. So here is our here is our problem. 24 equals that 15/100ths W. Okay, so we can use this now to solve for the our whole. Okay, so let me just leave that with you and see if you could use your powers of equation solving, isolating variables and dividing for one or whatever. You put it all together and see what you come up with, okay? We are now solving for the whole. Come on back when you're done and let's check it. Okay, so I'm going to go ahead and use this one here. 24 equals 15/100ths, or 15 over 100 W. I do tend to like the fraction representations better. If I'm going to do it freehand, using, of course, to do it on a calculator, you'd want to use the decimals. All right, so what I'm doing is I am isolating that W by multiplying it by its multiplicative inverse, okay, which is 100 over 15. Of course, I'm going to get my W right here, and then I want to do the same exact thing on the other side. So 24 over 1 gets multiplied by 100 over 15, which is that multiplicative inverse of 15 over 100. Go ahead and cross cancel. I get 800 over 5 equals W, and then if I do my division, 800 divided by 5, I'm going to get 160. So W, or the whole, is 160. So in this case, there would be 160 balloons, and 15% of that 160 would be 24. Now we can look at this visually. Two number lines, setting them up, percentages on the top. Okay, up to, this is my, didn't write this in, here's my percentage line, and then here is my balloon line right there. Okay, alrighty, balloon line right there. Hope that's not too messy to understand. Okay, but now what I've demarcated here, what I've done on that top line, and as I've seen, that 100 can very easily be split up into 5% pieces, which I've done right here, because there we would have 5%, 10%, 15%, and that's where our 15% is right there. So I have splitting this up into 5% pieces, which is going to be even. Okay, and if I do the same down the bottom, you can see that while each of these is, the top is 5% per line, on the bottom we have 8 balloons per line, which correspond correspond, which makes sense because we can see right here that 24 balloons is indeed 15%, okay, because we knew that up here, okay. So yeah, so lines are all corresponding. Therefore, up top, if I do 5, because each line is 5 increments, that would be 20 lines equals 100. So 5% per line, 20 lines all the way across. I won't do it here just because it's too tedious. And then the bottom, if I did that, I have 8 balloons per line. I would have 20 lines because that is going to split my line up evenly, just like the top line. And then you could see 160 is what I would come up with, and 160 is indeed my whole. So I've proven it visually as well. Okay, there's other ways to, of course, prove it just by multiplying 160 here by 15%. Okay, I could just go ahead and do that. And why don't I do that just real quick here? So 160 over 1 times 15 over 100. Okay, 15%. And let's see, I can do this and this, and see, what do I get there? Well, I get by 50, right? That would be, if I did this by 50, this would be 2, and divide this by 50. Can't do that. Let me stop that. How about by, well, 2, of course, is 50 and 80. But then I can divide that also by 5. So that is going to be 10 and 16. I think that's where we're at, right? Oh, darn. I could have just divided it by 10. Duh. Okay. Yeah, divided both those numbers by 10. Anyway, so yeah, if I do that, well, I can still further do this here, right? I could do that by 2. Did I just do that? 5 and 8. Oh my gosh, please excuse me. I am really acting very confused now. Okay, there we go. So 5 and 8, and again, if we multiply that across, 8 times 15 is what, 120, and then over 5. Okay, and that is actually going to be 24. Yep, there we go. 120 over 5 equals 24, which actually works out right there. Okay, because that means that 15% of 160 is 24, which is what we saw in our solution. Okay, so I'm going to let you go ahead now and hopefully try this yourself. And again, we're finding the percent given a part of the whole. Actually, why don't we just do this together, because it is an entirely, well, not entirely different. We're still going to use the percentage, excuse me, the percent formula and algebraic reasoning. But now we are going to find the percent when we're given the part and the whole. Okay, part of the whole and the whole. Okay, so let's go ahead and just read through this, and let's go ahead and identify the different parts that we do indeed have. So Haley is making admission tickets to the middle school dance. So far, she has made 112 tickets, but her plan is to make 320. So what percent of the admission tickets has Haley produced so far? Okay, so solve the problem using the percent formula and verify using visual model. Okay, so let's go ahead and look at what we have. So we have our percent formula, which equals part equals percentage times whole. Okay, all right, that's our percent formula. If we're going to fill this in right now, we have the part, because that's the so far part. She has 112 already made. We don't have the percentage. Okay, so that is, let's just say P times the whole, which is 320. Okay, 320. And so the way we can look at P times 320 more easily can be written as 320p. So now we're left with this. 112 equals 320p. I'm going to leave you right there because I want you to go ahead and solve that again like you did last time, just using your algebraic expertise, and come on back. Okay, so welcome back. Here's where I left you off here with 112 equals 320p. Hopefully you noticed that you could just go ahead and multiply by the multiplicative inverse of 320, which is what we did on the right side there, to get p, our singular p, because we are solving for p, which is percentage in this case. Okay, do the same thing on the other side. I'm going to multiply 112 over 1 times 1 over 320. And I kind of took me a few steps, but I did figure out, I did my cross cancellation here and figured out that 112 and 320 were related this way, 7 and 20. Okay, so what I ended up with was 7/20 equals p, not so easily recognizable as a percentage, 7/20, but if I go ahead and create an equivalent fraction over 100, because that is very easy, and in this case I can. It's a good idea because I have 20, which is a factor of 100, so it makes it a lot easier. And I realized that from going from 20 to 100, I multiply by 5. Therefore, I would do the same up top, 7 times 5, and that equals 35. And 35 over 100, or 35/100ths, of course, is 35%. Okay, I am really want to get this done before 50 minutes, so I'm not going to show you visually how this looks. If you did it visually to prove it, I'm very happy for you. Go back and look at other examples of visual proof if you want to, again, to see how to do that. Okay, so let's go ahead and summarize here. And in summary, I mean, the point they were trying to make, again, is going from all different ways, from trying to find the percent given the whole and the part, trying to find the part given the whole and the percent, trying to find the whole given the percent and the part. These are all things that can be done by just paying attention to this percent equation, okay? The percent formula, the percent formula, which is part equals percent times whole. Whatever you're given, you plug it in to this equation, and of course you're going to be left with 1, either the part or the percent or the whole as an unknown, and then you can just work your algebraic magic to come up with the answer. Okay, visual models are probably going to be more important to some of us than others, but they really are wonderful models to actually see these answers and these solutions come to life, because sometimes it's just a mystery, really what all these numbers mean. But again, percent, as I had mentioned in this in this lesson earlier, which I hadn't talked about before so much, but it's per 100, okay? And of course, we've said this over and over again, but why? Well, why is because it's easy, okay? It's easy. It's something we've become very accustomed to. Even if you had a class of 37 students, you are still going to calculate percent per 100, and that just means, hey, if you had 100 kids in your class, you would have blah 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 who would have gotten an A, okay, which is the same as 37% of just looking at a class of 37. Okay, you're looking at it in terms of a class of 100, but you're still calculating a percentage for your class of 37, let's say. Okay, 100, very easy to work with in terms of our numbers. Okay, anyway, that's how it is. We are only at 49 minutes at this point. Good luck on your problem set and exit ticket, and see you again.